this video, we're going to find the complete linear factorization of a polynomial. I'm going to start off with f of x equals to x to the third minus x squared plus 16x minus 16. I see that this one can be factored by grouping. That gives us x minus 1 times x squared plus 16. This sum of squares, a squared plus b squared, remember, could be broken down into a plus bi and a minus bi. This is going to be x minus 1, x plus 4i, x minus 4i. Let's look at the next one. X to the third plus 5x squared plus 4x minus 10. This one cannot be factored by grouping, so we're going to need to use our rational root theorem. Factors of 10 plus or minus 1 plus or minus 2 plus or minus 5 plus or minus 10. Let's go ahead and try 1, 5, 4, negative 10. 1 times 1 is 1. 6. 6 plus 4 is 10. 10 plus a negative 10 is 0. Gives us x minus 1 times x squared plus 6x plus 10. This is x plus just a second. This is x squared plus 6x plus 10 is going to be x squared plus 6x equals a negative 10. Half of this number squared is a 9. That's an x plus 3 squared is equal to a negative 1. X plus 3 equals plus or minus I. X equals a negative 3 plus or minus I. So this is going to be x plus 3 minus I and x plus 3 plus I. Now we're going to work on x cubed plus 6x squared plus 17x plus 18. And our rational root theorem tells us we have possible rational zeros of plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. Let me go ahead and try a negative 3. That's not going to work. Let's try a negative 2. There we go. So this is going to be x plus 2 times x squared plus 4x plus 9. And we have factors of x plus 2. It's x plus 2 minus the square root of 5 times I, and x plus 2 plus the square root of 5 times I. Let's try x to the 4th plus 20x squared plus 64. Because x squared squared is x to the 4th, I might be able to factor this with traditional factoring techniques. 64 is 4 and 16. So this is going to break down to x plus 2i, x minus 2i, x plus 4i, and x minus 4i. Let's work on x to the 4th plus 6x to the 3rd plus 12x squared plus 24x plus 32. We know because there are no sign changes in the original, there are no positive answers to this one. So maybe there's some negative rational roots when we try our rational root theorem, but we're only interested in -1, -2, -4, -8, -16, and -32 as possible answers. Let's try -2. 1, 6, 12, 24, 32. That looks like that's going to factor by grouping now. And we're going to break down that sum of squares at the end into its complex linear factors, like so. We have one more problem here in this section. Sorry, we have a couple more problems here. Let me go ahead and write these down, what these answers were here. This was x plus 2i, x minus 2i, x plus 4i, and x minus 4i. And this one right here. Go back to the previous answer so I can write it down. This is going to be x plus 2, x plus 4, x plus 2i, x minus 2i. There we go. Now we are on the last problem. Let's go ahead and clear this out. 2x to the 4th plus 5x to the 3rd plus 10x squared plus 20x plus 8. Again, we see that we're going to have no positive answers here. So we're going to have factors of 8 over factors of 2, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 1/2. 2 halves is 1, 4 halves is 2, 8 halves is 4. Let's try a -2. Gives me x plus 2 times 2x to the 3rd plus x squared plus 8x plus 4. I'm going to be able to factor by grouping now. That's what I meant. X plus 2 times 2x plus 1 times x squared plus 4. X plus 2 times 2x plus 1 times x plus 2i, x minus 2i, x plus 2, 2x plus 1, x plus 2i, x minus 2i. There we go. There's our complete linear factorization for all of these problems. If you wanted to pull the 2 out front in this one, you could do that and write it as x plus 1/2. That would also be acceptable. And that's it for this section. We'll come back and talk about something else next time.